This is a review of exponential and logarithmic functions of precalculus. So let's say we have a function 2 to the x, and we would like to sketch that graph and also its inverse. So let's start with the function 2 to the x. Okay, when x is equal to 0, 2 to the 0 power would be 1, so it's 0, 1. When x is equal to 1, 2 to the first power would be 2, so we would be going through 1, 2. And then when x is equal to 2, then y would be 4. Are you guys seeing the pattern yet? 1, 2, 4. The next one will be 8 and 16 and so on. What about the other side? Okay, when x is equal to negative 1, 2 to the negative 1 is 1 power is 1/2. It should be right here. When x is negative 2, 2 to the negative second power is 1/4, and so on. So this way, so this function would be asymptotic to x-axis, well, negative x-axis, then will increase like this, and hopefully everybody's familiar with this. Okay, now how can we sketch its inverse? Let's just say inverse function, hopefully you remember, f of x is equal to 2 to the x, which you write it as y is equal to 2 to the x. Then we switch x and y like this. Now, why would you want to do such a thing? The reason for that is because function is what input and output is basically set of x's and set of y's. And then this function f, with a given input, it'll give certain output. For example, 0, 1, and 1, 2, and 2, and 4, and so on. Now, what f inverse does is it's going backward now, isn't it? So input becomes output, and output becomes input. So naturally, do you see why we have to switch x and y now to reverse this action? Okay, switching x and y, what kind of effect does it have? I prepared a little bit of Desmos sketch here. So this is 2 to the x that we have. Now I have switched on the second one, x is equal to 2 to the y, which means I'm switching x and y. Lo and behold, the symmetry is very striking now, isn't it? So this is, as they say, symmetric across y is equal to x. Okay, now, not because your algebra teacher told you so, not because you memorized it as a rule, but why? Why would you have this kind of symmetry? Let's just talk about that. Switching x and y, for example, point here. This point here is a coordinate of 0, 1, meaning x is 0 and y is equal to 1. So if we switch x and y, then x would be 1 and y would be 0, which is right here. And this point right here, 1, 2, switch it, it becomes 2, 1. And this one, 2, 4, 4, 2. Do you see why it has to be so symmetric like this now? And then 4, 8, 8, 4. And this one you have to be a little careful. Negative 1, 1/2. So it's 1/2 and negative 1 right there. And negative 2, 1/4 would be 1/4, negative 2. So it would be right there. So it's asymptotic this way. So this is a natural phenomenon of switching x and y. After all, whatever is in x-axis will end up here. Whatever is in y-coordinate will end up here. So it looks like as if we have rotated this thing around about this line right here. And this line is, as we say, y is equal to x. Okay, for that reason we have this kind of symmetry. So let's come back to finding the inverse function. Now, this is what this inverse looks like. This is f inverse of x, where this one is f of x here, which is 2 to the x. Now we have to solve for this y. How do we do that? Up to that time, there was no better symbol for it, so mathematicians have created, regretfully, the worst notation in math altogether, and that would be log and little base 2 of x. So whenever you see this, these two are equivalent statements. Okay, now that gives us an insight on how to evaluate logarithm and basically what logarithm is. Okay, so let's take a few practice here. If you have log, let's say 2 to 8, we have that one here. When x is, what you're thinking is 2 to the something power is equal to 8. And what goes in the box? So that's 3. Therefore, this is 3. Okay, let's do another one. Log, let's say 3 to the 27. Well, that one will be 3 to the something power is 27. And do you see that we have to have 3 here? Oh, not by design, but I came up with exactly same example, or same answer, 3. Why don't I change it? Let's say log 3 to the 81 then. That means 3 to the something power is equal to 81. Okay, and that would be 4 then. Okay, now let's do something that's not as easy then. What about log, let's say 5 to the 1 over 25? What would that be? Well, that means 5 to the something power is 1 over 25. And do you see this has to be negative 2 here? Okay, last one, but not so obvious one. Log, let's say 4 of 8. 4 to the something power is equal to 8. Now we're stuck. Okay. When that happens, I mean, some of you can think, oh yeah, that's 3 over 2. In case you cannot think like this, just imagine some unknown number x. Okay, now we have to figure this thing out. See, 4 is 2 squared to the x power, and of course 8 is 2 to the third. Well, rule of exponents, hopefully you remember that. That is 2 to the 2x is equal to 2 to the 3. Well, that tells you x is equal to 3. So x is equal to 3 over 2. X is what goes in the box, so this is 3 over 2. How about that? Okay. Now, some other type of exponential and logarithmic functions while I have this Desmos. Okay, what happens if I increase this base to 3? Okay, having a little difficulty there. Let's type it in, 3. Then, did you notice this thing just got steeper? Okay, what about its inverse, which is log 3x now? I can change that to 3. Then this thing gets flatter that way. Okay, and lastly, but not least, most important number, e. It just got a little bit shallower now, right? I'm going to change this as well, e. Okay, now, so what is e? E is some number that is between 2 and 3, and a lot closer to 3 than 2. 2.72-ish, and that all happens to be a big deal in calculus. Okay, now let's do some exercises. So here are the problems. I want you to pause this video and work on these 3, then resume the video to check the solutions. Okay, we're back. Now, first one. This one we are thinking 4 to the something power is equal to 64. Okay. Do you all see 3 here? Okay, so this one happens to be 3.
Now the second one, 7 to the something power is 1 over 49. Okay, some of you might thought, wow, 7 squared, well, that's 49, not 1 over 49, but negative exponents takes care of that. So answer here is negative 2. Good. Now what about this one? Well, 32 to something power is equal to 4. Well, what can we do? Well, some of you can imagine the answer, but let's say you cannot. Then let's just put x there. And then let's see. 32, prime factorization. 2, 2, 2, 2, 2. So it's 2 to the 5th power to the x power is equal to 2 squared. So rule of exponent tells you 2 to the 5x is equal to 2 squared. Therefore, 5x is equal to 2. And 5x is equal, yeah. And x is equal to 2/5. How about that? So this is 2/5. Okay. In this second example, we'll talk about properties of logarithm. Okay, these are the 3 properties of logarithm that you might have learned in precalculus, and change of base formula. For me, this is property number 4. Okay, so let's just talk about change of base formula first. Why does it work the way it does? It's kind of weird. Only reason we do this is to be able to punch it into the calculator. For example, say log, we have 7 to the 10th power. Now, you are thinking that 7 to the something power is equal to 10. And since 7 and 10 does not have any thing in common, there's like no common base here, so we cannot really easily come up with this number. So we have to scratch this dot. So only way we can do this now is with a calculator. Okay, so calculator wise, and according to this formula and this, in calculus, all of you are taking calculus, natural log is the way to go. Nobody ever uses common log, so forget this altogether. So this would be log base e, also known as ln, of 10 over log base e 7. Okay, now that is ln 10 over ln 7. Okay, now then you take out your calculator. Okay, this is my TI-84. Then, see, there are only 2 log buttons, ln and common log. Okay, there is a function that you can actually enter this, but this is so much better way. So we press ln 10 divide by ln and 7. Okay, and this thing is 1.1833-ish. How about that? Just to verify, what happens if we use base 10 instead of base e? Let's just verify that for the sake of verifying. So if we do common log, which is base 10 of 10, divided by log 7, then as you can see, you get precisely the same answer. So it doesn't matter which other base that you use, and then there's no other reason to use any other base but these 2. Okay, so that's change of base formula. Now then, properties of logarithm. Okay, You might have just memorized this as a rule of logarithm. Log A is like multiplication becoming addition. What does that mean? Why is that true? I'd like to, well, without proving it, I'd like to at least try to convince you why that is the case. So let's talk about the first one. So if you have log A of U and B, let's just say log base 2. So your A here is happens to be 2 at the moment, of let's say 8. 8 of course is 32. Let's do 32. Okay. So log, this is 4 times 8. So will it be then equal to, according to this formula, if it's correct, log 2 of 4 plus log 2 of 8 then? That is the question now. Now we have just learned how to evaluate this logarithm. So log 2 of 32, let's review it. That means 2 to the something power is equal to 32. So do you all see 5 in here? So this number right here is 5. Okay? Now likewise, this number here is 2 to the something power is equal to 4. That means it's 2 here. It was 5 in here. So this number is 2. And this number is 2 to the something power is equal to 8. That means 3 is in the box. So the question is 5, this number really means it's 5, it's a number. Is it equal to 2 plus 3? And answer is, of course, yes. What's going on is very similar to this phenomena. When we had, remember this value here happens to be the exponents. Let me write this again. 2 to the something, and that something, this 5, happens to be this value of the log happens to be exponent, is equal to 32, right? So equivalent way of saying that is, this is 2 to the 5th power. Now here is 2 squared, and here is 2 to the 3rd power. How can we make this equality here? Well, if we multiply the 2, then rule of exponent would tell you that 2 plus 3 is equal to 5. Now, since the value of log is the exponent itself, and rule of exponent, when you multiply with two exponential function with the same base, you add the exponent. So that's precisely what's going on. So this first property is equivalent of rule of exponent, multiplication becoming addition thing. Okay, so likewise, you can see why the second one is also true. But let me just demonstrate quickly. So we can just play this game like this. Log of 2 of, let's say, 32 divided by 4, which is 8. So what was log 8, 2 to the 8 again? That was 3, recycling our work. Okay, now, would that be equal to then log 2 to the 32 minus log 2 to the 4th? Of course, we have done this before and right here. So this is 5 and this is 2. So what it's saying is 3 is equal to 5 minus 2, which is of course still true. Okay, now then third property of logarithm, this thing. So let's just say log 2 to the 4 cube. Is that too ambitious? Okay, that's 32. This number right here. Wait, 4 cube. What's 4 cube? 16 times 4, 64. So this number is 64. So let's just, so according to this formula, if it's correct, would that be equal to this thing, 3 comes to the front, 3 times log 2 to the 4. That's what it's saying. And once again, we can evaluate this thing. Let me push this thing down a little bit. Okay, so remember this number is 64, so 2 to the something power is equal to 64. And then do you see 6 here? So this number right here is 6. And then that is equal to 3 times log 2 to the 4th. We did that before here, 2. So what this thing is saying is, this is equivalent of rule of exponents like this. When you have 2 squared to the 3rd power, then exponents multiply, that's 2 to the 6th power. This is precisely what this is equivalent to. So hopefully this would convince you that rule of logarithm is not something that you just memorized as rule or property, but something that is naturally happening phenomena. Okay, having said that, let's take this example. This is a huge skill in calculus, so let's expand or condense. Okay, so let's learn how to expand this logarithm. Okay, so that, let me just rewrite this. That is ln of, hopefully you guys know this is x to the 2/3 power. Okay, and the next one is x plus 1 to the 1/5 power over, and then 4x plus 1 to the 1/2 power. Okay, and ln base e again. Now, then first we have a division. So what we have is ln x 2/3 times x plus 1 to the 1/5 power, and then minus ln 4x plus 1 to the 1/2 power. Okay, then now we have a multiplication, so that becomes an addition. So we have ln x to the 2/3 plus ln x plus 1 to the 1/5 minus ln 4x plus 1 to the 1/2 power. Now, using third property of logarithm, this exponents come to the front. So we would have 2/3 ln of x plus 1/5 ln of x plus 1 minus 1/2 of ln of 4x plus 1. Now, these things don't get any simpler than this, so just leave it alone like that. Okay? That was a lot of work. And you're wishing, now we are all taking calculus, would that be is there a faster way to do this? And answer is yes, there is. And let's see this. All you have to do is just imagine this thing. Okay, so ln x to the 2/3 power, right? First of all, this is multiplication and this is a division. So everything that's a multiplication on the numerator, it becomes positive, and only thing that becomes negative is what's in the denominator. So I can write this, and then instead of writing 2/3 power here, I write it here, applying the third property of logarithm right away. And plus space ln, and then x plus 1. And instead of writing 1/5 power, we just write it here, bring it to the front. And this is a denominator, so remember this is minus ln, then 4x plus 1. And instead of 1/2 power here, we write it in the front. And lo and behold, this is exactly the same as what we had before in one step. Okay, now we got some exercises. Once again, I want you to pause this video, work on these three, then resume to check the solutions. We're back. Okay, so first one, let's just see. This is a ln, let me rewrite it, x to the 4th power over y to the 5th power and z to the 1/2 power. Did you take several steps or one step? Maybe this one I should take multiple steps just to be careful and show you what's going on. Then I will show you how to get there in one step once again. So this one, ln x to the fourth power minus, and then you have ln y to the fifth power z to the 1/2 power together, right? Then that is ln x to the fourth power minus, then bracket, and these two, ln y to the fifth power plus, this is multiplication now, so becomes an addition, ln z to the 1/2 power. Now bring 4 to the front, so 4 ln x minus, could we distribute and then bring out the exponent at the same time? Hopefully that's not too much algebra. So we have 5 ln y, distribute minus sign, and then 1/2 ln z is the final answer. Well, could we have done that in one step? Let's see. So remember, whatever is in the numerator is the positive, and the others that are in the denominator, they both become negative. That's the only thing you need to remember. So what we have is ln x to the fourth power. This term is in the denominator, so minus, and then ln y exponent to the fifth power in the front. Another denominator, so once again minus, and then ln z and exponent 1/2 power. How about that? Not bad, huh? Okay. Well, then the second one. Part B. So we have log 5, 250. What is 250? Let's just think about that. I'll just write it like this. Log 3, well, let's just write it this much. 25 times 10 at least, eh? Okay. Then that would be almost the same thing as the first one. So this would be log 5 to the third power minus log 5 to the 25ths, and then another minus log 5. Let's just think about the 10. I'll just write it here, 10. Okay. Now let's simplify a little bit. So this is log 5 to the 3. Now this is 5 squared is equal to 25. So this number is 2. You all see that? And then this one happens to be log, once again, this is multiplication. So we have log 5 to the 2 times 5. 2 plus log 5 to the 5. So log 5 to the third minus 2 minus log 5 to 2. Distribute the negative sign, and that 5 to something power is equal to 5, and that's 1. So this one is 1. So what we have is log 5 3 minus log 5 2, and then minus 3 between this term and that term. Okay, and then you're thinking there's got to be a better way than this, right? Of course there is. It depends on how you view this problem. So let me push this next exercise down, and then I'll show you how to do this more efficiently. Okay, instead of writing it like that, had I recognized log 5 3, and this is 5 cubed times 2. Well, 2 times 5 cubed. See, 250. Of course, is 25 times 10, and this is 5 times 5, and this is 5 times 2. So 2 times 5 cubed. Let's just write it like that. Then we get to use our tactic doing this in one step. So recognizing the problem or rewriting it properly saves you a lot of work, as you can see here. So this will be log 5 3 for the numerator, and the other two become negative. So minus log 5, 2, and then another minus log 5 to the third power. Now, so these two remain the same, but this one, 3 comes to the front, and whatever's left, log 5, as we figured out here, that's 1, so it's just 3 times 1, and so this is it. How about that, huh? Okay, now let's practice how to combine these into single logarithm, and the term here is condensed logarithm. Okay, once again, pause this video, work these 3 problems out, then resume, then we'll talk about it. We're back. So A, first, let's say this 2 goes up, so this is same as ln x squared minus that 3 goes up to become the exponent. You're applying the third property of logarithm, reverse way. So ln y to the third, and that 1/2 becomes the exponent, so plus ln z to the 1/2 power. Then we combine into one single logarithm, so ln fraction. Only thing that's in the denominator is this -1, so y cubed here, then x squared, and then z to the 1/2. And once you get good at it, then you can do the whole thing in one step. Okay, now let's talk about b here. B, log 5 to the 75 minus log 5 to 3. Well, that is, first this is log 5 and 75 over 3. Right? You with me? Okay. And simplify fractions. So this is log 5. And we have 25. Good. And then let's see what's log 525. Log 525 is 5 to the something is equal to 25, so that's 2. How about that, huh? Okay, now C. 1 minus 2 ln 5. Well, you get this much. So it's 1 minus ln 5 squared. But how do you, what is this 1? What do we do? Right? Could that be some kind of log? Now, my question is, what is ln e? Let me just write it as log e, which is ln, and we have to do something here, right? And that needs to be 1. Rewriting this into exponential form tells you e to the first power is something. That's certainly e. Let's just check. Well, log e to the e, yeah, that's 1. So we recognize this thing can be written as ln, now ln log e, like that. Now we can combine the two. So that is equal to single ln e over 5 squared, which is not 25. How about that? Okay, on the second example, we are solving exponential equations. Okay, first one. 1/5 to the something power is equal to 125. Well, do you see 5 in here and 5 in here? So let's just write it in terms of base 5, shall we? 5 to the -1 power is 1/5 to the x is equal to 5 cubed now. Rule of exponent tells you you multiply, so 5 to the -x is equal to 5 to the third power. Aha! So x must be -3 then. Okay, that was pretty easy. Okay, second one.
We see nothing in common. 7 and 22, really nothing. So we are stuck. Okay. There are two schools of thought, depending on which book you subscribe to. I believe your Algebra 2 book did it this way. Rewrite this into logarithmic form. So x is equal to log 7 to the 22nd. Okay. Now we use the force property, change your base formula. So we have ln 22 over ln 7. Then we punch the calculator. So let's do that. So we do ln 22 over ln 7. Okay, so that answer is 1.5885. Okay. And your Precalculus book, I believe, did it this way. We have 7 to the x power is equal to 22. Notice that I put a little space here. And then we can take common log on both sides like this. And then third property of log tells you that x come to the front. So I have x ln 7 is equal to ln 22. Now, since we are solving for x, we divide by ln 7, so we have ln 22 over ln 7, which is precisely the same answer. Okay, now we have this problem. Okay, now you're thinking, could we take ln on both sides like this? Right? No, you don't. Functions, including ln, there are very few functions. Functions in general don't distribute. Okay, so don't be doing that. Like one good example is square root of a squared minus b squared is not equal to a minus b. Okay, one way we can see that is square root is a function, it doesn't distribute. Let's say 9, which is 3 squared, minus 4, which is 2 squared, right? This is not equal to square root of 9, 3 minus 2. Not even close. Okay, so let's not ever do that. Okay, so likewise, what we can do here is, we have to recognize this is quadratic form. Let me rewrite the quadratic form here so you can recognize it. Say we have, instead of e to the x, let me say if y is equal to e to the x, then this equation becomes 2y minus 5 is equal to, what is this, 3y to the negative 1 power? That just simply is 3 over y now, isn't it? How can we solve this? We multiply y on both sides. Y here and y here. And that way, we have 2y squared minus 5y is equal to, and y is here, cancel 3. And then this gives us quadratic function. Okay? Now, do we have to do it this way? No, we don't. We can just multiply e to the x on both sides. And let's see what happens. So distribute, so we have 2 e to the x squared, or we can just write it like that. That's just e to the x squared minus 5 e to the x, and e to the x cancels, so this gives you 3, which is exactly similar to this. While we are at it, then let's bring it over. So minus 3 is equal to 0, which is equivalent to this. Now we just solve this quadratic formula or by factoring. In this case it factors, and that's as if this is some other variable y.
So let's review factoring then. So we have e to the x and 2 times e to the x, okay, is equal to 0, and this is negative. I'm going to write both of them as negative for now, and I need to subtract and get 5, so I want 3 here and 1 here. That way this thing gives you negative 6 e to the x, and this thing gives you, in order to have negative 5, I need positive e to the x, so change that to positive. You get factoring? Okay then. So now either the first term is equal to 0, meaning e to the x is equal to 3, or second term is equal to 0, so e to the x is equal to negative 1/2. And here ln both sides, or we write into logarithm, however you view it. This is ln 3. Do you see the problem with this? And if you don't, then this will enlighten you. X is equal to ln and negative 1/2, and you're saying, what's wrong with it? Well, let's see here. So what we have is ln 3. That is a nice number, 1.0986. So this is 1.0986. What about the second one? Okay, so we have ln and then negative 1/2, negative 1/2. Okay, what is this, right? This is some kind of complex number. So the reason you're having this is because it's not a real number. Let's go back to the beginning, or graph, right? Instead of going back, I have decimals still saved here. So see, logarithm does not take any negative value. The domain of logarithm has to be positive only. Easier way of seeing that is exponential function can only give you a positive number. So here the problem is right there. E to the x has to be positive only and cannot be held negative 1/2. So this has no solution. So we could have recognized that earlier and saved us the trouble. And this is the only answer. Okay? Well, what about this kind then? This, first we have to combine these two. So let's see, we have log 2 using the first property of logarithm. So we multiply x and 3x plus 10. So we have 3x squared plus 10x is equal to 3. Then we rewrite this into exponential form. Remember 2, and that's exponent. So we have 3x squared plus 10x is equal to 2 to the 3rd power, which is 8. Now bring it over. So 3x squared plus 10x minus 8 is equal to 0. Okay, let us factor. So we have x here and 3x here. Okay, once again we're subtracting because this is minus, and we're supposed to have positive 10. Okay, let's see if we have 2 and 4. So I want 4 here and 2 here. Write both of them as negative for now, and this gives me negative 12x, but I want positive 10, so I want that to be positive. And this gives you me negative 2x, and together that gives you positive 10x. So that tells you this needs to be positive. Okay? So that's equal to 0. That tells you x is equal to either negative 4 or x is equal to 2/3. Now when we said, okay, that's just dandy, we have 2 different answers. Not so fast. Remember, logarithm only takes a positive number. Domain of log has to be positive, not even 0. And what happens if you substitute negative 4 here or here? Cannot have negative number inside the log. By the way, don't substitute it in here. That will still give you the right answers. It'll check.
you have to substitute it to the original. So now we have to reject this one and then keep this as the only answer. Good. Okay then. We have exercises. Okay, these 3 problems on your worksheet. Okay, I want you to pause this video and work on these 3. Then we'll talk about it afterwards. So go ahead and pause the video. Did you get it? Okay, let's look at the first one first. So we have 2/3. This one color. 2/3 to the x. And could we? It's okay. 2/3 to the x. 81 is of course 9 times 9, which is 3 times 3 times 3 times 3. So this is 3 to the 4th power, and 16 here, 4 times 4, 2, 2. So this is 2 to the 4th power, which tells you 2/3 to the x. Now we like everything to be 2/3. Do you see that? This is 2/3 to the -4 then. How about that? That way, rule of exponent tells you find the reciprocal and take 4th power. So I'm missing x there. So my x needs to be -4. Good. Okay. Now this one. Let's figure out what 256 is. On the left-hand side, 2 to the x plus 3. Not much we can do there. But 256. Okay. What do you want to divide this by? 4. 64. Well, 8 times 8. And this is 2 times 2. 8 is 2, 2, 2. So how many 2's we have? 8 of them. So this is same as 2 to the 8th power. But that tells you then x plus 3, well, this thing is equal to that thing, is equal to 8. Therefore, x is equal to 5. Good. Okay then. Let's look at C. A little bit. Okay. Ooh, decimal equation. Let's take ln on those. Well, it's the same thing. Yeah. But let me rewrite it like this. 5 to the negative t over 2. This one is 1/2. No, I just don't like decimal that much. Okay. Let's take ln on both sides then. So we have ln 5 to the negative t over 2 is equal to ln 1/2. Okay. Now this thing come to the front. So we have negative t over 2 ln 5. By the way, did you notice this is the same as negative ln 2? What? I mean, it's okay if you don't do it this way, but this is same as ln 2 to the -1, and you can bring that to the front. Okay, now we want this t. So t, who am I kidding? Let's do it in 2 steps, right? Negative t over 2 is equal to divide by, so we have negative ln 2 over ln 5. Then we multiply by -2, so t is equal to 2 times ln 2 over ln 5. Let's take out the calculator. So we have, and we preferably want to do this in 1 step. And your calculator is smart enough to do this. Watch. ln 2 divided by ln 5. Like that. And then we have
0.8614. How about that? Okay, we have another set of problems, logarithmic equation this time. So we have these two problems, and I have one more. Okay, that problem. I can bring it up so you can see it on one screen. Okay, I want you to pause this video and work on these problems, okay? Then we'll come back and talk about it. We're back. So this first one, A. First, let's combine these two logarithms. We have the same base, so we can say log 4 x over x minus 1 is equal to 1/2. So far, so good. Now we have to rewrite this into exponential form. So this is the exponent. That's the only thing you need to remember. So we have x over x minus 1 is equal to 4 to the 1/2 power. 1/2 power is same as square root. So this is square root 4. So we have x over x minus 1 is equal to 2. Continuing up here, so multiplying x minus 1, so x is equal to 2x minus 2. Subtracting x, so we have x here, and then adding 2, so x is equal to 2. Okay, and let's see if that, let's check if that gives us a correct answer. So we don't really have to check, we just need to see the domain problem. So 2 here, no problem, 2 here, no problem. So this is good. Okay, part B. And I'm going to push this back down now. So combining logarithms, so we have log 3x over 8 minus, pardon me, x minus 8 is equal to 2, and say this is 3 to the second power. So we have x over x minus 8 is equal to 3 squared, and that is 9. So we have x over x minus 8 is equal to 9. Multiplying x minus 8, so x is equal to 9x minus 72. Continuing up here, so subtracting x, so we have 8x on the left, 72 here. So x is equal to 9. Oh, let's not forget to check 9 in here. Oh, that barely makes it, and it's okay here, so we're good. Okay, lastly, this problem. This time we have plus here, so we have to multiply. So ln x minus 3 x plus 3 is equal to 1. Let's multiply that out. So that is ln x squared minus 9 is equal to 1. Write it into exponential form. So we have x squared minus 9 is equal to, base here is, remember, this is natural log e. So e to the first power, which is just e. And what is that? We don't care. It's e 2.72-ish. So x squared is equal to 9 minus e. And of course, x is equal to plus or minus square root of 9 minus e. But let's check. See, we cannot put -1 here because that will make this thing negative. Might make this thing negative, but we don't care. This is already negative. So we have to throw away one of the negative signs. So x is equal to just positive square root 9 minus e. How's that?